I'm Patrick Coleman, and this is Rob Silva. And we chose to make a drone for agricultural purposes. And so first we have a special camera arrangement. So the drone takes up the cameras, and then the cameras record special information. And then this is a Tri-Copter. It's the basic form layout. And right here you can see the tail rotor moves left and right. And then the other fans are coordinated with pitch and roll. And then for one of the things we did to demonstrate some functionality was I really need navigation lights. So the green is right and the red is left. So that's the normal convention for navigation lights. And then the white is the tail light. And then the blue is a status light for something I'm doing up here. So then these would be attached to different arms so that I could see while I was flying. And then here's Rob.
Okay, what I did the coding for the cameras. So while he's flying over whatever your acres out or whatever, you can fly over vegetation. It has an NVDI camera, which could determine stuff that's living and stuff that's not living. So if someone was to fly from, like over the acres of whatever vegetation they had and something was dying, they could see this particular area and give it attention, whether it needed water or food, anything like that. So basically it's sweeping and it's close for about a couple of seconds in each position, 45, 90 degrees, and 135.
So is it taking video or still pictures?
It's still pictures, and they're coordinated just by pressing the buttons at the same time. Eventually, we'll run two wires off the buttons, and a single transistor will turn them both on.
And why two cameras?
One of them is reading normal RGB, okay?
RGB is?
Red, green, blue. Okay, so just a normal digital picture, and this is one of the scenes. And then the other one is seeing blue. It has the red channel has been reassigned to near infrared, and red has been blocked. So you see the majority is green and blue, but really it's almost entirely blue. So then what you can do is you can composite these two images, and what you'll get is you'll get an image, and these are my images, but this one is not. That's typically what you get. So you'll take an infra blue image, which you saw, and you'll compose the two and you'll get this. So you can see where the gravel road is, and it's gray, white, black, gray, exactly as you would expect because it's not alive. Okay? Then you start seeing blue, light blue, where things are kind of unhealthy. Right along where the grass meets the road. Okay, and you see some of that, and you'll see some of that in the distance. Then you'll start getting green and yellow where things are extremely healthy, you see? Then you'll start getting orange and red where things are really healthy. And in the above image, if you saw the RGB one, you would see the foliage was very healthy. Once you get into the extremely pink color, it's starting to get very suspicious that the camera isn't working right or that the data is insufficient. So we marked everything between -1 and 0.1 as suspiciously not photosynthetic, and anything above 0.9 to 1 is suspiciously high. So everything between 0.1 and 0.9 is a good indicator of health or lack of health. So that's why the NVDI camera is so valuable. You can fly it over acres and acres, and you can redress just a 30-foot by 30-foot section of land or crops as being healthy or unhealthy. So that becomes a huge advantage in micro agriculturalism. You can put limited pesticides or no pesticides. You can put water or less water right where it's needed and right when it's needed. You can often figure out when plants are about to wilt 3 days before they do. So you can detect stress before the plant even shows it. So that's why I'm so interested in NVDI. So I'm Patrick Coleman.
Rob Silva.
Yeah. And this was our project.
Thank you.